trick. Good morning, everyone. Welcome to this next session here titled Smart Load Control, Current Options to Avoid Panel Upgrades. I have Alex Sloan here from Electrify My Home. Alex is the VP of Operations at Electrify My Home. He leads business operations and development, and uh, Alex has a master's degree in energy systems from UC Davis, carries over 10 years of experience designing and implementing energy efficiency programs. In addition to electrifying homes and buildings, Alex manages content creation for Electrify My Home's training programs. The coursework that he has helped develop has been delivered in more than 100 contractor and homeowner trainings on a multitude of different electrification subjects. So Alex has quite a bit of experience delivering this type of content, and I personally cannot wait to see what he has in store for us today. Folks that have any questions, please put them in the Q&A or in the chat, and I will field those at the end of the session. Alex, please take it away. Thanks.
All right. Thank you, Armando. Thank you to the BEST team for having me on. Really excited to present to you on one of our favorite topics here, which is avoiding panel upgrades. Other folks might call it the Watt diet. We like to call it good electrification, but it's all getting down to the same thing. As we try to start electrifying as many homes as possible, we need to be mindful of the panels. So just to kick things off, we always like to include our mission statement. I work at Electrify My Home. We're out of the Bay Area in California. And we provide the most efficient, cost-effective electrification solutions, practice good stewardship of the electrical panel, and train and influence other contractors to do the same. So we're actually out there installing heat pumps, heat pump water heaters, induction ranges, you name it, new panels, circuits on a weekly basis. So we're a practitioner. We also train other contractors and homeowners on our approach. And we believe so strongly in the importance of being a good steward of the electrical panel that it's in our mission statement. So just kicking off with the importance of electrical panels. And most of this talk is going to be focused on residential electrification. So, quick analogy that helps me put it into context. We think of electrical infrastructure as the brain of electrification, right? So a panel in someone's home is going to be the center point for their current and future electrification opportunities. And then heat pumps are the heart of electrification, right? The two go well together. But first, we need to make sure we prescribe the right heat pump for the right application, which is something we talk about in most of our other trainings. And we don't want to fill our brain, or in this case, the panel, with garbage. So as we start to look at typical residential electrical panels, you might look at some and see something that looks like this and ask yourself, are these panels full? And we get questions from homeowners all the time saying, hey, there's no more slots available in my panel. What do I do? So having a full panel in terms of no space does not mean that there's no remaining capacity necessarily. So on a typical 100 amp panel, we actually have 24,000 watts, and on a 200 amp panel, 48,000 watts to work with. And that's actually a lot of capacity. When we break it down a little bit further, this is a chart from SMUD customers in Sacramento. And what it shows is on the bottom, peak kilowatt demand. So the max power they used at any 15-minute interval across the span of a year, that's what's kind of posted here. And then the number of each customers of either mixed fuel, so they have gas in the home, or all electric homes in orange. And the main takeaway here, on the previous slide, we just said that a 100 amp panel, which is considered small in many cases, actually has 24 kW. That's off the charts here. So what we see is that when you look at the actual consumed power and energy data for an electrical panel, we're not using anywhere close to the max availability of that panel. Here's just another example. This is actually an example from my house in Davis, California. And over the course of a whole year, my max KW came out to 6.56 kW. House was built in 1959 and has been fully electrified. I have a 2-ton Mitsubishi system for the HVAC, a heat pump water heater, an electric range, and a resistance dryer. So we do have lots of capacity usually to work with. So that brings us back to our question here. Are these panels actually full? Well, technically, yes, there's no available slots, but it doesn't necessarily mean that there's no available capacity left. And so that's what brings us into kind of the next portion of the conversation. So with that said, we have capacity, but does it meet code, right? And so when we look back at this chart showing that we almost never reach the peak demand allotted by our panel, we actually have to plan ahead for worst case scenarios, which is why we need to follow the National Electric Code. And that's what brings us to the tendency to want to oversize our electrical panels is for safety reasons, right? So the NEC requirements are in place to prevent overheating of the wires and the bus bars, and it's really in place for safety. So there are a whole other presentations on this, but we have 2 options to meet the National Electric Code requirements. There's a top-down method where we can look at previous 12 months of billing data or metered usage and do a little bit of math, multiply it by 1.25, and then add in the nameplate rating of all new proposed appliances to see whether or not we can successfully install those appliances on an existing panel. So that's sort of one method, pretty rare. The more typical one is the bottoms up approach, where we go throughout the home and take the different nameplates of the main appliances, electric using appliances in the house, figure out what their demand factors are, or essentially, what their nameplate is combined with a discount rate for certain appliances that aren't running all the time. Because usually in our home, we're not using every single appliance all at once. And then some do require 100% what's called a coincidence factor, because they may be running for longer periods of time, such as an HVAC system. So we put all those together, and eventually that's going to spit out a result to say whether or not we can continue utilizing the existing service, right? So let's say we start with a 60 amp or 100 amp panel, and we want to add in a new heat pump water heater circuit. We'll want to do one of these load calculations to see if our existing panel can actually do that while meeting code. Okay, so that's where things start to get a little bit tricky. So what's wrong with panel upgrades? Why not just go in and upgrade all our panels? We know everyone's starting to march towards electrification and taking out gas and replacing that with efficient electric counterparts. Shouldn't we just go ahead and upgrade panels? Well, not always. So there are a few challenges inherent in service panel upgrades. For one, they're typically quite expensive. So we're usually looking at $4,000 plus. And if there's an underground feed, for example, and the wire is too small coming from the utility, a homeowner might need to trench and break up concrete, and it's very invasive and extremely expensive when we go down that route. Other challenges, if the electric meters within a few feet of the gas meter, there are restrictions, at least in our area, from the utility, from the electric utility, that make it much more challenging to go through that upgrade process. And then there are utility challenges. So if you as a homeowner want to upgrade your service from 100 to 200 amps, and that upgrade flags calculation for the utility saying, no, the transformer serving this block is going to need to be upgraded if we let that customer have a bit more service. That makes things extremely complicated. And then beyond all that, in order to do that process, the utility has to do an upfront engineering, which adds additional fees. So if we can avoid panel upgrades, it's our company's point of view that we want to do it whenever possible. One caveat to that, of course, is always safety, right? So if we come across a panel that's one of these older styles that are known to be having some inherent safety risks, it's always better to reconsider the approach there and prioritize the upgrade if the panel is not in good condition or if there are some safety concerns, right? So always caveat that anytime we're talking about the watt diet or any of these capacity reducing strategies, we always need to be safety as number one. Okay, so narrowing in on what do we do, right? So how do we get homes fully electrified on a 100 amp panel, which is usually the situation where we need to get a little bit creative, or even on a 200 amp service where it's a bigger house, or we want to electrify the house in a means that meets the customer's lifestyle. And so we'll run through some different options here that are tried and true and tested. We've been doing these things for the last 3 or 4 years at our company. So let's roll through it. First, what loads to consider? So when we're talking about electrifying a whole home, these are the most typical appliances that we're looking at bringing over from gas to electric. And also what physical space and capacity is needed in an electrical panel. So we also have some decisions to make along the road while we're prescribing these, which is why we feel very strongly that any practitioner, any technician should understand the different services in the house beyond their trade, right? So if you're an HVAC technician and you see that the customer has all gas appliances, you should take that into consideration and do a very short analysis or even back of the envelope calculation ahead of time to say, okay, we can put in this heat pump, but that's going to restrict your ability to electrify a whole house, right? So important to consider the customer's whole journey up front, particularly when it comes to things like EV charging and things like induction cooking, which are massive loads potentially. So to try to make this point a little clearer, let's roll through an example showing one of the panels that I brought up earlier, right? So our challenge here is that we want to add a heat pump water heater circuit to a house with a panel that has no additional slots available. So here are some options to make that happen. Option number one, we say quad it out. We can add a quad breaker, which is a breaker that has narrow slots that can fit in place of the existing 2-pole 240 volt breaker in the panel. So this is a great space conserving option if the panel is compatible with quad breakers, right? And so of course we need to do our panel calculations and ensure that we can add a new breaker to begin with, but this is a great way to alleviate space issues. Another great option, and let's say, this alleviates space issues, but it also alleviates panel capacity constraints. Circuit splitting. So we do this all the time. The way a circuit splitter works is that we can take an existing 240 volt circuit from the panel and split that into two, ensuring that only one will run at any given time so that we never exceed the allotted capacity of that breaker. So just as an example, we can put a dryer on one side and an EV charger on the other side. We have this example for a heat pump water heater. We try to avoid installing heat pump water heaters on a circuit splitter if possible, just because of the inherent needs to ensure we always have hot water. But in some situations, we have done so with some great success. And there are several different products on the market that now make this really easy to do. The other great thing about circuit splitting is that we can avoid costs of running an additional circuit in some situations, which can be a big cost saver on the electrical side for a new EV charger, a new heat pump water heater, or you name it. Another nifty option is circuit pausing. So it works very similarly to a circuit splitter. But the way a circuit pauser works is instead of sharing the circuit, instead, we're going to add two monitors on the main feeds into the panel through this same kind of box. And the box is going to be constantly monitoring the feed here. And as soon as the total power consumption of the house rolls above 80%, which we saw in the data rarely happens, then it's going to shut off the circuit to the, let's say, heat pump water heater or range or whatever 240-volt appliance you want to add to ensure that the panel is going to stay in the safe zone. So we've also used this from time to time. Works really great for homes that don't want to sacrifice the sharing of two different circuits, and also has space to add these CTs around the mains. These are current transformers. Okay, another just space-saving constraint. If we've got plenty of capacity in the panel from our load calculation, a great option is to add a sub-panel, right? And this is an important way to help the customer plan ahead. So we often run sub-panels that we're running all the new electrified appliances off of, right? So we'll take this dryer circuit, replace it with a sub-panel, place the dryer circuit in the new sub-panel, as well as any new circuits that we need to feed. Again, to do this, we want to ensure that we have sufficient capacity in the main panel to begin with. And then, a quick tip for those practitioners out there, add the neutral in case a customer wants to go through and add some of their own additional breakers down the road. Okay, another great solution, adding smart panels. So we've been doing more and more of these. Smart panels there are several new options on the market. I'll just mention one of them here, the span panel. The way this works is that you can set a max capacity for the house. So if you have a max 100 amp feed, for example, you can tell the span, hey, our max is 100 amps here. So anytime we start to get up towards that 100 amps, I want you to start shutting off this breaker, then this breaker, then this breaker. So the customer can go through and determine which loads it wants to shed at any given time. They'll also get great feedback on the energy use of all the breakers in the panel, and it could serve as a critical loads panel for a battery system as well, being able to do the same thing of prioritizing which loads stay on or off. So another neat, a little bit more sophisticated solution of managing load control. Okay, and finally, just instead of doing a 240-volt larger capacity heat pump water heater, add a shared circuit 120-volt unit, right? So these units are now on the market. We need to be careful about when we add them, but they do exist now. And on that same theme, we call watt dieting starts with low power appliances. So this is always a great first solution. All the ones shown at the top here are 120-volt options to decrease the load to begin with so that we can squeeze more into lower capacity. So I won't run through the whole example, but we can see here under a sample situation with standard appliances versus power efficient appliances, we can take the total sum for these new appliances from 20,400 down to 9,000, right? So this is where pre-planning really comes into play. So I'll close out there. I know we've only got a minute or so. Feel free to stay in touch. If you want to learn more on this topic, there's a lot of great resources out there. I've linked 2 QR codes here. The first is on a 4-minute case study from one of our projects where we did several of the solutions I presented here, as well as a more in-depth hour-and-a-half webinar that we've done on the topic.
Thanks a lot, Alex. And I always really appreciate seeing people wear their appropriate PPE while in the field.
Sir.
I wouldn't expect anything less. So a couple of questions. One from Heather Burpee. Basic question: how does a homeowner know what capacity they currently have, either 100 or 200 amp, for example?
Yeah, it's a good question. The easiest way typically is to navigate to your main panel, and there's something called a service disconnect, and it should have a number right on that specific breaker. Now, some of the old panels don't necessarily have a service disconnect in there. So if you got a really, really old panel, you might need a little bit of help. But usually there's a way to identify the main feed breaker by looking at the service disconnect labeled one.
Thanks. The next question here from Robert is, does anyone make a smart sub panel?
One comes to mind. There's a company called Savant, and they came out with a pretty neat. Um, uh, it's not necessarily a smart sub panel, but it's a module where you can take a breaker and tie it into a smart like mini load center and be able to control an individual breaker in a sub panel that way. And in that way, it kind of becomes a virtual or separated critical loads panel, which, if you wanted to add a battery and a critical loads panel, you'd have to put everything into one panel. So that's a great option. Also, the span panel I showed you is technically like you can use that as a sub panel. So you just replace your sub panel with a span or some of the other smart breaker solutions that are out there. There are more and more each day.
All right. Well, Alex, thank you once again. Really appreciate you taking the time to educate us on this topic today. I think that's all the time we have here. Kim put the link to the next session in the chat. We'll see you guys at the next session. Thanks again, Alex. Talk soon. See y'all.
All right. Thanks, everybody. Happy electrification.